we will prove the algebraic identity. Now here it's a big shape and the shape is just like a square, and the name of this square is A, B, C and D. So how we will prove this algebraic identity? Now we have to cut these shapes, all these shapes. So there are three shapes. Small one is a square and this is another big shape, it's also square, and these two shapes are rectangle. Now G, H, F and D is a rectangle, H, I, C and F is a square, H, I, B and E is a rectangle, A, E, H and G is a square. So this means that we have two squares and two rectangles, but these two rectangles are the same length, have same length and same width, but these two squares have different sides. Now when we will cut these shapes, now first of all we will cut this small shape. This small shape is a square. Now when we cut this small square and put it over here, and we know that if it is a square, so all these sides are same, so that's why we will write the length is x, length is b and the width is also b. Now here inside it's a square. Why it is a square? Because we know that in indices when the bases are same, their powers are added, so both the variable has power 1 1, that's why it's a b square. Now another shape is a rectangle. So rectangle is G, H, F and D. So when we will cut this rectangle, after cutting this shape, and we will paste it over here, and due to the property of rectangle we know that their opposite sides are same. So if it is A, this one is also A, and if it is B, this one is also B. Now the third one is also a rectangle. So when we cut this rectangle, suppose this is rectangle, and we will paste it over here. Now we know that these two rectangles are the same one, so if it is, its length is A and width is B, same is its length is this one and its width is B, and we know that if it is a rectangle their opposite sides are same. If it is a, this one is also A. If it is a B, this one is also B. Now the third one is, this is a big square. Now when we cut this big square and paste it over here, and this is a square, and if it is a square we know that their length and their width both are same. So this is A and this is A. So when we pasted, we will cut this side and paste it over here, it will make a big square, and we know that this is, it's one of its side. So this side is of the small square is B, and this side of the rectangle is A. So when we add this complete length, it will be A plus B. On the other side, if this side is B and the other side of this square is small a, and if we consider this complete length of the big square, this is A plus B. Now we have two sides. This is a square and both the sides are same, A plus B and A plus B. Now we know that area of square is equal to side whole square. Now here in this case, the side of this square is A plus B. So that's why we will substitute the value A plus B whole square. Now right side is here. Now we have to find out the left hand side. Now area of square. Here, if you pick this square, the big square, and put it over here. So this is a square, and we know that the area of square is side square. Now this area is side square, and we know that this one is a square, so one of its side is A. So that's why we will write A whole square. Now if we pick up another rectangle, this one, and put it over here, and then add this area, so another area, we will apply the same formula, but here in this case it's a rectangle, so here we will use the formula area is equal to length multiplied by width. So the length is A into B. Then again we will pick up this same rectangle and paste it over here. So again we will apply the same formula. This is area length multiplied by width. So it's a length is A, width is B. So we have to add these areas. So length into width plus, then again we will pick up the smaller square and paste it over here, and the area of this square is area is equal to side square, because both the sides are same. So that's why we will substitute this value B. That's a B square, which is further equal to, all the areas are added, area of big square, area of two rectangles, and area of small squares. All these areas are added, which is equal to this side square. So A plus B whole square. Now A square plus, now when you multiply these two variables, both are different, their powers are not added, so simply we will write AB, same is the case here, AB plus B square, which is equal to A plus B whole square, so, which is further equal to A square plus, now these two variables AB has constant value, and the constant value is, here is 1, here is also 1. So these two values, 1 and 1 is added, so it will be 2ab plus b square is equal to a plus b whole square, or it can be written as, therefore a plus b whole square, which is equal to a square plus 2ab plus b square. So this is our final required proof of algebraic identity.